In this session, we are going to talk about regression analysis when your outcome variable is ordered categorical and you want to do a logistic regression. The inspiration for the example I'm going to use is taken from this paper titled Food Cravings, Binge Eating and Eating Disorder Psychopathology, exploring the moderating roles of race and gender. In this case, as always, I've departed quite a bit from the study, but I've used this as inspiration, so I thought it would be nice for you to maybe have a read. So let's go to our study and see what it is we're trying to answer as a research question. I have now opened MPlus. Now, you would use a logistic regression when your outcome variable is ordered and categorical. So in this case, our research question was, which type of food cravings leads to more binge eating? And we had two predictors, food cravings for fast food and food cravings for sweets. The outcome variable was binge eating on a 3-point scale, never, sometimes or rarely, and often. The other thing you see here is that I have already linked the dataset to the MPlus input file, and under the variable command, I listed the names of the variables in my dataset. Next, we have to tell MPlus which variables we're actually going to use in this model. So for this, we would say use variables. And in this case, we're using all three of them, so I'm just going to copy-paste them here. Then we have to tell MPlus that our dependent variable, which represents binge eating, is ordered categorical. For this, you would have to say categorical, and then you just put binge. Then, in order to perform a logistic regression, you would have to tell MPlus to use the maximum likelihood estimator. This goes under the analysis command. So you would say analysis estimator ML. And finally, you would have to type out the model. In this case, we have two regression paths. One from fast food cravings to binge eating, and the other from sweet cravings to binge eating. You can write it one per line, and don't forget it's always outcome regressed onto the predictor. So you would say binge on and put a predictor here. You can also put both independent variables here, and then you would shorten it to one line. So you could just say fast and sweets. So this now will perform both regression paths. So this is all you have to do. You can save the model and press run. You will now have run your logistic regression. The first thing you see here is a repeat of the input instructions. Then you scroll down and you get this message which confirms that the input reading was terminated normally. Next, in the analysis section, you can see you had just one group of people and 500 people in the sample. There was one dependent variable and two independent variables. No factor analysis was included in this model. So this is not actually an SEM. It's just a regression analysis. You can also see that the outcome variable was ordinal. This means it was either binary or ordered categorical. The observed independent variables were cravings for fast food and cravings for sweets. And finally, you can see the estimator used was ML. If you scroll down a bit more, you will also notice that the link used was Logit. This means that a logistic regression was performed. Scrolling down a bit more, because this is an ordered categorical variable, you get this section here. It tells you how many people you had in each category of response for binge eating. So for example, in the category of never, you had 63.2% of the sample, comprising 316 people. In the second category, which meant sometimes or infrequently, you had 7.4% of the sample, and therefore 37 people. Finally, in the category of frequently or often binge eating, we had 29.4% of the sample, comprising 147 people. Next you have the univariate sample statistics, which gives you a range of descriptive statistics. You can check them, of course, but I hope by this point you will have already looked at the descriptive statistics in your data management software of choice. Next you get another message that is very important, which tells you that the model estimation was terminated normally. This is another place in the output file where you might get warnings or even errors. Underneath you get the model fit information. So you would get the log likelihood value and the Akaike and Bayesian information criteria. You can use these two to compare across models. So for example, you might want to compare a model that uses a logistic regression with a model that uses a probit regression, which we will see in the next video, in order to decide which one is better for your data. Underneath you get the model results, which represents the unstandardized solution. These numbers here are the regression coefficients, and they are in the form of log odds. They are both positive and significant, as you can see here. This means that the likelihood of binge eating increases for people who have an increased craving for both fast food and sweets, and the path from sweets is stronger. However, to more easily interpret your results, you will probably want to look at the odds ratios. Let me tell you how to interpret these coefficients. Let's take the first one. The first coefficient is 2.422. This coefficient tells you that people who have heightened cravings for fast food are 2.4 times more likely to switch from the category of no binge eating to sometimes, and from sometimes to frequently. The second coefficient tells you that people who have heightened cravings for sweets are 4.5 times more likely to transition from no binge eating to sometimes, and from sometimes to often. Now what you can see is that with this test you don't know exactly where the difference is or the switch lies. You have three categories of response: never, sometimes, and often. And therefore you have two transitions, one from never to sometimes, and one from sometimes to often. This model relies on the proportional odds assumption, which means that the two transitions would be equal in strength. So therefore your predictor is assumed to influence each of the two transitions in the same way and to the same extent. Now, in order to see whether this was a good assumption to make, what you can do is you can check the Brandwald test for proportional odds. You get this just underneath here. So, if the chi-square tests are not significant, then the proportional odds assumption was met. In our case, the p-values were not significant both overall and for each of the two predictors. So therefore, our odds ratios are a good interpretation to say that heightened fast food cravings and heightened cravings for sweets make you more likely to transition upwards between two categories of binge eating. So this is essentially the model and the results. I want to give you one quick last detail of how to transform these numbers into odd ratios. For this, I'm going to open just one calculator that I have obtained online by simply typing in scientific calculator into Google. So now on the left-hand side I have the model, and on the right-hand side I have the calculator. In order to transform the log odds into odd ratios, you simply have to exponentiate the log odds. So you basically take the log out. What you have to do is you have to say e to the power, and the power will be the number you have here. So in this case it's 0.884. And this gives you 2.42. Now this number is not exactly the same as the number you see here, and this is because I have reused rounded values in my calculation. Let's try the other one. You would say e to the power, and then you would use the log odds here, 1.519. And the result you get is actually very close to the odds ratio result here. This is it. Follow me in the next video to see how to run this as a probit regression instead of a logistic regression.